Hello and welcome. In this video I'm going to explain what the Pythagoras theorem is and how you can use it. Now what is the Pythagoras theorem? So the Pythagoras theorem is a rule that we use in trigonometry, so the geometry of triangles, to find out an unknown length with a right angled triangle. Now what is a right angled triangle? Here we have a triangle where one of the sides is equal to 90 degrees. And we draw that using this square in the corner, which is basically showing that this angle here is 90 degrees. This is the definition of a right angled triangle, where one of the angles is equal to 90 degrees. Now the last thing that we need to know is the hypotenuse. Now the hypotenuse is the longest side on a triangle in length. So in this case, right here, this would be our hypotenuse. This side right here, as this side, this length is longer than these two lengths. Another way to remember it, with right angled triangles, the hypotenuse will always be opposite the 90-degree angle. Now, how does this relate to the Pythagoras theorem? Well, the Pythagoras theorem states that a squared plus b squared is equal to c squared. Now, what is a, what is b, and what is c? Well, c, with the Pythagoras theorem, is the hypotenuse, so is this length up here. Now, a and b are interchangeable. They can be this length or this length, so we'll label this a and we'll label this b. Because a squared plus b squared is the same as b squared plus a squared, as long as c is the hypotenuse. Let's try an example up here. So we have 3, 4, and our unknown value. So we can call this c already. So let's first write out the equation. A squared plus b squared is equal to c squared. So let's plug in our values here and then solve for c. So we're going to get 3 squared plus 4 squared is equal to c squared. 3 squared is equal to 9. 4 squared is equal to 16. Add these two together, that gives us 25 is equal to c squared. Well, that's really convenient because 25 is a square number, so we can square root both sides to cancel out the 2 to give us 5. So we know our hypotenuse is equal to 5. This is a very famous example, the 3, 4, 5 triangle, and we found it using the Pythagoras theorem. But let's say we are given a triangle, but we're already given its hypotenuse, and we need to find another length. So what we can do, we first write out our equation, but in this case, now we're trying to solve for a or b. So what we need to do is we'll plug in our values again, but we need to rearrange the equation to solve for our other unknown. So let's name this b, and let's name our hypotenuse c. So we're going to get a squared plus 8 squared is equal to 10 squared. That gives us a squared plus 64 is equal to 100. Now we can minus 64 from both sides. That will give us 36. This is also convenient as both sides are square rootable. So we square root this, this cancels out, and we get a is equal to square root 36, which is equal to 6. So our unknown length in this case is not the hypotenuse, but we rearrange the equation to get our unknown. Thank you for watching, and I'll see you all in the next one.